everybody, I'm Rafaela, and I'm gonna share a bit of my experience and lessons learned about blockchain applications. So a bit about how you can test the benefits, challenge, type of tests and testing tools, and also the future of blockchain, and also a bit about me as well. So let's start. So yeah, I have 13 years experience on QA and test automation, test strategy, test architecture as well, and leadership. Basically, my entire family works with IT. My dad used to be Visual Basic developer, my mom a COBOL developer, and my oldest brother used to be a C++ developer. So I started to learn coding when I was 6 years and was with Clipper, so a long time ago. I got really passionate about the QA area, and then I created this blog where you can find posts about QA, leadership, DevOps, and also programming tips. I also have this Twitter account. You can follow me there. I just used to share my blog posts. To be honest, I'm not really active, but you can follow me anyway. And I don't know if you can notice it by my accent, but I'm actually from Brazil. To be more specific, a seaside town called Santos. And you can see the picture of my hometown on the screen with the palm tree, of course. So if you ever go to Brazil, remember to order pizza there. You get surprised about the flavors, and also order the famous feijoada, which is a stew made of sausage, beef, and black beans. I moved to London 7 years ago, and yeah, here I am. I'm really glad to be here as well. 4 years ago, I was on the other side watching the talks and doing the just like the workshops there. I learned about machine learning, so it was really great learning all these things. So I'm glad to be here on the other side now. Um, so yeah, let's talk about what is blockchain. So blockchain is the name of a whole new technology. Some people think that is Bitcoin. So blockchain is not Bitcoin. Bitcoin just uses blockchain as the technology, basically. And as the name states, it's a sequence of blocks or group of transactions that are chained together and distributed among the users or nodes. It works as a record of transactions that do not require to rely on external authority to validate the data. And you can see the 5 key concepts of the blockchain technology on the screen. So you have the cryptographic hash, immutable ledger, the consensus protocol, P2P network, and we have the mining as well. Let's just talk a bit about the problems that blockchain is promising to solve. So we know the trust between people fall apart when it comes to money. People have to trust a third party to, just discuss these numerous amount of problems in our day-to-day lives with where we are sending the money, where is it? Is in the bank, and we know that as this system comes with its own defects. For example, a bank may be closed, or your accounts might get frozen, or the bank itself might go bankrupt, right? So blockchain comes exactly to solve these problems because you won't have this third party. Anyway, it's good to have freedom to do whatever you want with your money, isn't it? So let's just go and try this real world example. So imagine that you have a group of friends that decide to figure out each other's expenses. And for that, you agree to share each other expenses and announce when a new expense is created as well. And with that, you need to solve a mathematical problem. and share the solution with the group of friends. So, and the first person that solves this problem gets the chance to verify the integrity of the expense. Then the person share how the mathematical problem was solved, and everybody can verify if the problem was solved in an acceptable manner. If it was solved correctly, then everybody is going to reference this expense using a code. And this code is going to be added to the next block that had the mathematical problem solved and the related expense as well, and so on until the end of the chain. The P2P, the network, is the group of friends validating the transaction, and the consensus is the agreed acceptable way to solve the mathematical problem. Mining would be the person trying to solve the mathematical issue. Hash would be the code used to reference the expense and the mathematical problem. And the immutable ledger is the agreement about nobody being able to change a block with the expense and the solved problem that was already validated and accepted by the P2P network, by the group of friends. So this is a real world example of the blockchain technology. So now we can go a bit deeper on the concepts, right? Let's start with the hash. So the hash is a cryptographic function that transforms any input data into fixed length of string of numbers. I'm gonna share a bit like the example a bit in the future of these slides. So one of the most important features of the hash functions is exactly that conversion is just one way. You cannot reverse the function to generate the original input, but every time that you send that string or that sentence is gonna be always the same code. The immutable ledger is basically a feature that is tightly related to the previous one, so related to the hash. Since every block of the chain contains the hash of the previous one, it is not possible to modify any block without changing the entire chain. So imagine when you are doing a Git commit. You just keep adding new commits, even if they have an error, you basically cannot revert and fix that error and push a new commit. What you do is, without changing the, the log, basically you add a new commit, fixing that problem, but then the bug is still be there, like it's still going to be in the chain. And if an anonymous attacker removes, adds, or modifies any transaction in the first block, the hash one will change. And if the hash one changes, it means that the hash two is going to change as well, because the hash one from the first block is included in the block two. Then this hash two that is contains the block two is going to contain this change as well. And the error is just going to propagate to every block of the chain after the block under attack. So before the attack, nothing is going to change, but after the chain is going to be completely different. And then the user will then declare the chain invalid. So now the P2P network, the blockchain doesn't need any external or internal trust authority. This is because the data is distributed among all the users. So basically the group of friends that you have in the first example. And every user has its own copy of the transactions and hashed blocks. They spread, so they share the information to the entire network, and everything is really transparent. This way is not possible for anyone to alter the information in the chain, since it is not started by a single entity, but for an entire network of users. So everybody in your group of friends, they have the same information and they share. Everything is transparent. You don't have just one person controlling everything like, third party like banks. Once a block of transactions is validated, it is added to the chain, and every user update their local information. And even if an attacker were to modify your local chain, the network will not accept any block from the altered chain. Then it comes to this consensus protocol, which is basically the agreement about the validity of the chain before we can add new blocks. Every time a node adds a new block, all the nodes have to validate this block by using a common protocol, which would be the mathematical problem solved from the first example. So typically, the nodes reach a consensus about the correctness of a new block by what we call proof of work or proof of stake methods. And then the nodes check the new block meets these requirements of this proof of method. And if the block is valid, they consider it as part of the blockchain and keep adding new blocks. So basically, they keep adding the new expenses as well in the transactions from the first example. Now we can talk about the mining and the block validation. This feature is actually not really necessary for a blockchain, but you can have non-mining networks like Ripple, the crypto Ripple. But I know that mining is a really famous, like popular term used a lot because of a Bitcoin, because you need to mine Bitcoins. But it's not really necessary for a blockchain. So the term mining refers to the act of meeting these proof of work requirements for adding a new block with pending transactions to the blockchain. The proof of work usually requires the user to create a block with restriction on the hash code, and the hash code is unpredictable, so nobody knows what it's going to be. It's like the mathematical problem, right? Nobody knows what is the result. So the miners, they have to test any possible combination before meeting these requirements. Once a miner node or a user finds the solution to the proof of work problem, they add the block to the chain, and every other node check the validity according to the consensus protocol. So basically, it's when your friends go and check if the mathematical problem that this one person solved is correctly or not, and is acceptable or not. And yeah, so we can talk about the benefits of blockchain apps now. Well, by now that is decentralized and transparent, so everybody knows what's going on, the transactions. No need to have a middle agent for the transactions. And well, you can use blockchain for like tracking ownership, digital assets, physical assets, and even for voting rights. Exactly, because it's decentralized and it's transparent. You can also have more security as it's immutable. So as this uses multiple nodes to complete and authenticate transactions, you don't rely only on a transaction system that is controlled by centralized group of identities. And then it comes to the example of the hash that I said I was going to show you. So you have the string, the message on the top, then you have the cryptographic function that is transforming this message on this string of numbers, basically. This is one way, so every time that you send this message is always going to be the same number, but you cannot go back, basically. You cannot revert and try to figure out what is the message. So yeah, another benefit is the authenticity and is auditable. So as I said, everything is transparent, so everybody can check where this transaction came from and where it's going. So allows the unique algorithm to process data like a fingerprint, the hash. Another benefit is the increase of the capacity of the entire network, as it is completely decentralized and real people can verify the blockchain. So it's basically one thing is really related to the other one. So as it's transparent, you can audit the transactions. The security is really good as well, exactly because of that. So yeah, these are basically the benefits that are really related to the other one. They are really coupled together. So we can talk about the challenges now, which is it's it's really complex to understand the technology. I just gave like really the basic here, but even if it is, you still need to go a bit deeper, like trying to understand what to do with blockchain that doesn't have the mining part, for example. So the details they go, and we need to go a bit deeper when we are trying to test or even develop or just work with blockchain apps. So the first challenge is exactly about understanding the technology. Then we have the problem that is the lack of testing tools, exactly because the community is still exploring the best ways and how can be used. So yeah, it's not really there yet, but we are going to go there at some point. One of the questions that you can think of is how do you fix like a defect that has been deployed as part of an immutable smart contract, for example. You know that if you do something in one of the blocks, this is gonna like just replicate until the end of the chain. So how do you fix that, right? Lack of blockchain testing tools. I have done some research. I'm gonna talk about that a bit more in the next slides, but basically you don't have too many testing tools, and the ones that you have, the documentation is not great as well. But yeah, it's just the beginning of blockchain technology. And yeah, selecting the right tool as per application is one of the most important decisions. So for this decision, you always need to do, and as this is a new technology as well, you always need to do your research before starting testing these blockchain apps, because everything is evolving too fast. So designing the test strategy, this is another complex part, exactly because you need to have a good understanding of the technology and do the research with the of the testing tools. And then, yeah, this is complex and will take a lot of time. And then we can talk about the block and chain size. This is really specific for blockchain apps. You need to make sure that the application is not gonna fail just because didn't have a proper validation, and it's not creating like a false positive verification on the block and chain size. Integration testing, this is common in any other application, to be honest, but yeah, you need to make sure that all the components are properly integrated. And you need to perform some kind of performance and load tests. This goes to any type of application as well, just to make sure that you have a better insight of how the application is going to perform in the real world, and what are the limits and how scalable is the chain. You can check the example that was done to Ethereum blockchain with CryptoKitties. This is a web application, like a game that was created exactly to test the performance of Ethereum. So if you check it right now, this is one of the problems of these crypto. They need to fix this performance problem, and they said that the Ethereum 2.0 is gonna fix these performance issues. But basically, this web application that you can check, you can create your own catch there, was created exactly to test the performance of the blockchain. And another challenge is the security. Exactly, securing the data should be the most important thing in a blockchain application, right? To be honest, in any application right now, because we have a lot of problems with sharing data with people that sometimes we don't know where it's going, and we have that problem with identity theft as well. This is quite common nowadays, and it's just gonna evolve, and so we need to make sure that security wise we are doing everything that we can to protect the data in the blockchain application, any application, as I said. But yeah. Type of tests for blockchain apps. So here we need to talk about the interaction between applications in the blockchain ecosystem, and that they are working together. So this is quite common in any type of application as well. It's not only for blockchain apps, but yeah, you need to make sure that you do some kind of API testing and block peer nodes testing. This is specific for blockchain apps, but you need to make sure that all the blocks on the network they have been tested like individually, to ensure they are proper connecting and communicating with the other node and other block, and if the hash is creating correctly and all these things. So one of the questions that you can think of is, do the nodes in the network sync with other validating peers? So you need to make sure they are syncing together when they are sharing the information. Another one is, for example, is the integrity of the network and shared ledger maintained through the testing. So, it's not like missing data, or is not transforming the data when you are sharing and doing the tests. So this is kind of part of the functional testing as well, because this is exactly how the blockchain should work. So apart from this test, you need to make sure that all the other functional parts of the blockchain, they are working together. And then you have the performance testing that I said before. This is something that you need to worry as well. So details like network latency based on block size and network size, expected transaction size, and how long a query takes to return the output with the authentication protocol. So basically the response time of the transactions. And then maybe doing some spy tests, trying to figure out what is the limit and the capacity of the blockchain, like Ethereum did. This is really important as well, and what is one of the most complex parts. Security testing, as I said before, we need to ensure that the application is not vulnerable to attacks, and the systems can protect the data and are capable of handling these malicious attacks. And during the integration test, we need to ensure that all the components of the blockchain application are integrated properly and performing the actions. So this goes to any type of application as well. Integration test is really important, and it's gonna save a lot of time. Instead of doing like end-to-end tests, you can do this way before. And the last one is the smart contracts testing. Refers to validate transactions meeting predefined conditions and business logic. So if you have done any type of contract testing before, the concept is the same. You have these fields that you need to make sure they are working as expected when you send expected variables and you send expected values. But you also need to make sure what is gonna happen if you send unexpected variables or values to these fields. So you need to make sure that it's not gonna break the system or break the blockchain or add a new vulnerability, and also check if they are triggering the right transactions. Now we can talk about the blockchain testing tools that I said they are not really great in the market right now, but this is evolving. So I have tested some of them, not all of them. Ethereum tester, I had a look before, and the truffle as well. I particularly liked these ones. But yeah, we don't have too many tools available right now, and the documentation is not great. But this Ethereum tester, it is an open source testing library, so you can check on GitHub this one, and it's Python. So if you know Python, it's really easy to set up. It's a script language, right? So you can check that they have API support as well for various testing requirements. This is really great. Bitcoin J, it's a Java-based framework built just for Bitcoin-based apps and enables you to interact with the real Bitcoin network. Populous, this framework has testing functionality of Ethereum with features for the contract deployment. So you can test contract deployment with Populous. This one, yeah, is the one with the documentation that I think is not there yet, but you can find this one good to have a look as well and get used to that. It's Python and is developed around PyTest. So it's quite easy to implement as well if you know Python. Truffle, this one is really popular among the Ethereum developers, which brings good testing features such as automated contract testing. So you don't need to worry about them when you're doing the blockchain testing. You don't need to worry about doing manual tests on them. Embark, it is a Ethereum test framework that focuses on developing decentralized applications and runs on various systems or nodes. So yeah, this one is Ethereum as well. Most of them are Ethereum. Bitcoin is the only one that Bitcoin J is the only one for Bitcoin blockchain apps, to be honest. But probably there are more, but this one is the most famous. And then we have the future of the blockchain. So yeah, we talk about all these benefits and challenges, and also the tools that we can use to test. But what is the future, right? What is this going to be the next phase of the internet? Some people they think that is. I do think it is as well, but it's gonna take some time to get there. So even though blockchain is often discussed in financial services and cryptocurrencies, this technology offers a broader range of potential applications. So it's not only about money and banks. The blockchain technology is permanently evolving and provides a lightning fast, cheap alternative to establish cross-border payment methods for all business types. But you don't need to worry just about payments. You can use about any kind of transactions, data transactions. Cybersecurity is one of the most promising areas for growth of for blockchain technology, exactly because businesses of all sizes are going to face ever increased issues with threats of data hacking, right? As I said before, data is one of the most valuable assets, like one of the most valuable things that we need to worry about. People using as to steal your data and pretend they are you. So yeah, this is a problem that blockchain comes to solve it. It can prevent such attacks. It allows data to remain secure while allowing active participants to continually watch the blockchain and verify every transaction's authenticity. So as I said before, it's transparent. So if there is something wrong, you can check, you can audit the transactions. It is predicted that blockchain technology will be seen as the most important innovation to emerge from cryptocurrency boom. So yeah, nowadays is really used for is more popular because of the crypto currencies. But in yeah, as World Economic Forum said, reported that by probably by 2025, 10% of the global gross domestic product is going to be stored on blockchain or blockchain based technology. We are 4 years until there, but yeah, I think it's gonna be maybe even more, to be honest. And yeah, that's it. Thank you. I have shared my LinkedIn, my blog, my Twitter, and GitHub there as well. If you have any questions, you can ping me on there. Um, but if you just want to follow me, of course, I'm always up to extend my network. So yeah, that's it. Thank you all.